allowable stress and factor of safety, right? And part 3, ialah we have strain, right? We have strain, right? Alright. This is revision of your attending. This is your attendance, alright? Most of you have done it okay, but some of you got the answer wrong, and some of you cannot answer, cannot solve this question. So I will repeat a little bit, right? So if you have a diameter rod in this question, we have a diameter rod of BC is 10 mm, alright? So find the maximum load P can be applied, alright? Given failure ultimate stress for rod BC 400 megapascal, alright? So use factor of safety is 2.0. So remember, so stress, you have the solution is force over area, alright? So what is this stress? So stress is depends. If it's given to you failure stress, so you need to divide by safety factor. So this one is become 400 divided by 2.0, right? So this one is force over area, right? So which force? So this given the ultimate stress for rod BC. So you need to find the force for BC, right? So same thing, you need to draw the free body diagram. So at A, pin, okay, at A you have pin, so you need to have AX, you have AY, and you have P, and you have this force, FBC. Why we have only one BC? Okay, why don't we have FBCX and FBCY? Because this is two force member, right? Remember, two force member, we have 2 points where the force may exist. So this is two force member. So direction is in this way. Alright? So we have FBC. Okay. So just find the equation for this free body diagram. So you find moment A is equals to 0. So you have P times 2. Alright. Minus because it's clockwise. Plus FBC 4 over 5 times 3, right, is equals to 0. Okay, so you have 12 over 5 FBC is equals to 2. All right, so what is FBC? FBC is 10 over 12P, right? 10 over 12P, right? Uh, 10 over 12 is equals to 0.83, right? So B, right? So you include this equation into that. Okay, so you have 400 divided by 2 is equals to 200. So you have 2 Pascal equals to force. Force is FBC lah. Force is FBC, so 0.83 P over area of BC. Alright, pi pi r squared. Alright, so pi r is 5 square. Right? 10 is diameter, so the radius is 5. Okay. So take your calculator. You can find the value of P. Wait, 200 megapascal times shift pi times 25 divided by 10. P. Is it correct? We have P times 2 and then FBC 4. Oh, it's not 4 over 5, it's 3 over 5. Right? Wait. This one is okay, this one is 3 over, okay, because this is 3, okay, 3 over 5. Alright, so you have 9 over 5 here. You have 9, so you need 9. Right, so you have 9 over 5 over 10 over 9 lah. Right, so here also wrong. This one is over 9. Over 9. Right, okay, you have 200 times pi times 25 times 9 divided by 10. Right, so you should get your answer of 1 kilo. Alright, so the maximum load P, if you remember, your answer is 14, 7 and 28. So the answer is 14 lah. The maximum it can sustain. If you put P and P right, P more than 14.14, see this root BC will exceed 200 megapascal. Alright, so that's the solution for your previous exercise, previous attendance. Alright, ada soalan tak? Any question? So this question you have one this type of question you have one in final exam. Okay, so you need to exercise more. Right, okay, we go into next topic, which is strain. Alright, previously we learned the stress is force over area. Alright, this is stress, which is force over area. Right, now we go into strain. Alright, we go into strain. Ada gangguan lah. Siapa yang tak off? Boleh off mic tak? Can you off your mic because boleh off mic. Siapa yang tak off mic ya? Alright. So we continue our the strain. All right. So the strain, we have the elongation or contraction of a line segment per unit of length is referred to a normal strain. All right. So strain is basically elongation, right, of a line segment. Let's say you have a bar like this. All right. We pull this bar in this side. Right. Let's say this is P and this is P. Okay. And then it will stretch, right? It will stretch. It will stretch like this one. Okay. It become longer. Right. It's become longer. Right. So this length, okay, this longer, we refer to the delta L lah, basically. Alright, let's say this is L initial and then this L final. Alright, L final. So strain is basically changes in length over length initial. Alright, or LF minus L initial over L initial. Alright, delta length over initial length. Alright, that's the normal strain. So the symbol is basically epsilon. Right, so the symbol for the strain is epsilon. This one is symbol for the stress, sigma. Symbol for the strain is epsilon. Alright, this is epsilon. So elongation divided by initial length. Alright. So if you have this one also same. Alright. We have delta S prime minus delta S over delta S. So delta S is this one lah. Right. So kalau kita ada A ke B ni panjang this length. Alright. And then it's deformed like this. The curve. Right. So the final one, this one, minus the initial, this one, so divided by initial. Alright, so you should have this, some sort of same equation. Alright, so final minus initial divided by initial. So you get the strength. Alright, strain pula. Strain. Alright. So the unit is basically, it can be meter over meter, or it can be mm over mm. It's length over length. So you have meter over meter. Alright. So if the normal strain is known, then the approximate final length is delta S prime is equals to 1 plus epsilon delta S. Alright. So this is basically you just rearrange this equation so that this equation. Alright. So if we rearrange this one, right, you have C epsilon delta S over delta S prime minus delta S, right? So we bring this to that side. So you have epsilon delta S minus delta S is equal to delta S prime. Okay. So delta S prime is equal to sigma S1 epsilon minus 1. Minus 1 kan? Or plus 1. You have sigma S minus 1. So this one is plus, and then it's become plus. So you get same answer lah, like this one, right?
Doctor, can you repeat once again?
This one, okay, I repeat again. So if you don't like this one, this symbol, you can rearrange as it is L minus length initial over length initial. Okay, same thing. All right, same thing. So if we rearrange this epsilon times delta S equal to delta S minus delta. Okay, we rearrange this into this. All right. So it's become delta M equals to epsilon delta. Then the is to delta S epsilon plus. All right, the same equation lah with this one. All right. Okay. So delta S prime is final length. Delta S is initial length. If you don't like this one, you can use also like this, right? So final is to shear length along. Okay, you can also use this equation. Same thing, only the symbol. All right. Some students don't like to
Thank you,
use
Doctor.
delta prime or not prime. All right. Okay. So unit is a dimensionless. So you can also write as a mm over mm. All right. Okay, that is a normal strain. Normal strain. Okay, if you have normal strain, we can also have the shear strain, like a stress. You have normal stress and you have shear stress. Okay, for the shear strain. Okay, let's say you have one rectangle. All right, and then we put a force like here. We put a force, and then this rectangle will become like this. Let's say lah, example, become like this. It's deformed like this, right? It will deform. Then the shear strain is basically this angle, right? This angle. Let's say this one is sigma, gamma, and this one is gamma, right? So gamma is basically 90 degree minus pi. So pi theta is this one, right? This one is gamma, this one is theta. So shear strain, this one, shear strain is basically 90 degree minus theta. So theta is this theta, right? The deformed shape of the rectangle. So you left with this one. So unit is radian. Alright. So same thing here. Pi. Pi over 2 minus theta prime. Right? Minus theta prime. Okay. So pi over 2 is 90 degree. Alright. So don't bother about the limit. Okay. You can simply ignore the limits. Just minus the theta. Okay. I repeat a little more. You have this box. And then it's deformed. Let's say it's deformed like this. We push this force, and then it will deform. So this is your theta, and this is your gamma. So is 90 over theta. Okay. So basically not 90 degree, you need to change this into radian. So 90 degree is pi over 2 minus 3. Okay. So a shear strain. So most question will ask you regarding the normal strain. So shear strain is basically not so popular in the question. Okay, it's just for your knowledge, right? So this is example. This is normal strain, and this is shear strain. All right. So normal strain. Let's say this one is X, and this one is Y. So you have normal strain in X direction. Let's say this one you will have A, and this one you will have B, right? Here you will have A also, okay, and here you will have B. So this one is your let's say length, right? Length. So sigma epsilon x is basically the elongation, right? L final, and this one is your L initial, Li, right? So your epsilon in x direction is basically 2a over L initial, right? So the elongation of this bar, so if we stretch this bar into this part, so you have 2a over L Li, all right, elongation, all right. Okay, so for the shear strain at A is basically pi over 2 minus theta. So theta is this one. This one is theta, right? So this one is your shear strain, all right? So as simple as that for the normal strain and shear strain. Okay, just remember shear is strain is delta L over L initial. That's it, right? So example, let's say we have force P is applied to a rigid lever arm ABC. The arm rotates counterclockwise about pin A through an angle of 0.05 degree. Determine the normal strain in wire BD. Right? So we have force P, this force, rigid level arm ABC, this one, A, B, and C, right? And then this arm will rotates counterclockwise, right? About pin A with angle of 0.05 degree. Determine normal strain, right? So counterclockwise is basically this direction, right? So when they rotate, it will this wire is become longer. Okay, so it will become like this, right? So this is 0.05 degree, and here is elongation. This one is delta L. Can we find delta L? It's easy, right? If we redraw this rectangle, okay, so this one is delta L. This one is 0.4 meter, right? And here is 0.05 degree, right? So delta L is basically tan 0.05 degree is equals to delta L over 0.4, right? So delta L is basically tan 0.05 times 0.4, you get 3.49 times 10 to the power of minus 4. Right? So that's delta L. Alright? So normal strain is delta L over L initial. So you have 3.59 times 10 minus 4 over L initial is 300 mm or 0.3 lah meter. Right? So you get the answer 1.16. 1.16 times 10 minus 3 meter over meter. Right? So this is your normal strain. Okay? This is your normal strain. Right. So this is the schema. Alright, this is your schema. So you can use also this method, but it's very tedious lah. Alright, or you can use our method just now. Alright, you can use this method to find the epsilon. Okay, yeah. In this method, they use so many angles. Alright, it's up to you if you're familiar with any method. You can go through this solution, so you will get the similar. You get the same answer. Right? This use a lot of trigonometry. Use a cosine law and sine law. Right? So example number 2. For example number 2, we have the plate like this one, right? Okay, you have plate deformed into this dash shape. If in this deformed shape, the horizontal line on the plate remain horizontal and do not change their length. Determine average normal strain along side AB and average shear strain in the plate relative to the X and Y axis. Right? What they want is, number 1 is average normal strain along side AB. Right? Where is side AB? So this is side AB. So this is side AB before it's deformed, and this is side AB after it's deformed. Alright? So normal strain for AB is change in delta L over initial length, or length final minus length initial over length initial. Alright? So length final is basically this length. Okay? This change color. Basically this, the blue one, the final length. Right? So you have the L minus L initial over L initial. Right? The blue one is the final length. Alright? So you need to find the length of this and divide by that one. So basically you have LF minus LI. Length initial is basically easy. You have 0.25 over 0.25. Oh, sorry, this is not an F strain. Right? That's strain. Wait. Mm, okay, how to find A, B prime? Let's say this is B prime. Okay, so how to find LF? Okay, how to find LF? You need to use the trigonometry lah. Alright, so this length is 0.2 meter. This one is 2 mm. Alright, and this one is 3 mm. This one is 3 mm, and this one is 2 mm. So AB prime, you need to use right. So you have, if I redraw this triangle, you become this. Okay, this is A, this is B, right? And then this is 3 mm. Okay, 3 mm. So here is 250, right? Here is 250 minus 2, all right? So you have 2, right? 250 minus 2, you left with 248 here, right? Okay, so AB equals 5 is equals to 4 and then square root lah. Okay, so you get the answer 248 squared plus 3 squared, you dapat 24.018 m. Okay, so you get the answer. So this one is 2.018. So sigma is 248 minus 2 divided by 2. Okay, so you get the answer 248.018 minus 250 divided by 250. So 7.93. 3 times 10 minus 3. Unit is mm over. You can use meter or millimeter. It's up to you. Right. So this is your final answer. Okay. So question number 2. Find the average shear strain in the plate relative to the x and y axis. So this is x and this is y axis. Alright. So find the normal strain. Okay. Shear strain. So shear strain is pi over minus. So theta is this one. This theta. Okay. So pi over 2 minus theta is equals to gamma. So this is gamma. Right? So gamma is basically this one lah. This gamma. Alright. I think this is a simple method. So you have tan inverse 3 over 2. Betul ke? Okay. So you have gamma is equals to tan inverse 348 tan inverse 3 over 248, you dapat 0.93. 0.93. 3/248 shift radian. Jadi dapat 0.693 degree. Okay, so you change to radian. Okay, you change to radian, you get the answer. Kita tukar radian lah. Darab 3.14 0.01 radian. So degree to radian, we just 0.693 times 3.4 degree. Okay, to get answer in radian lah, 0.1. Right. Okay, so you get the answer for the normal strain and okay, I can refer this slide as well. Right, so ada soalan tak untuk chapter 7? So we done with chapter 7, right? So untuk shear strain ni agak susah, so you jangan susah hati. Sebab soalan yang kita tanya biasanya normal strain lah. Basically we ask you the normal strain. So normal strain, just remember, okay, if we have this length, it's put in this way. So normal strain is basically delta L over L initial. That's it. Okay, regarding the normal strain. Okay, this one is your length initial. It's your delta L. Alright. Okay, ada soalan tak? Any question? We're done. 20 minutes. Alright. So if you have your file, you can open the tutorial number 5 in YouLearn. So we can go through some of the question. Alright. You can go through some of the question on the tutorial 5. Okay. We have around 1, 2, 3, 4, 5, and 6 question. Right, I think I can go some of the question today with you. Right, let's start with let's say question number 1. Question number 1. We have AB and BC weld together at B and loaded as shown. Determine the magnitude of the force P, which the tensile stress in rod AB is twice the magnitude of the compressive stress in rod BC. Okay, if you remember our lecture last 2 weeks, okay, how to find the sigma AB and sigma BC. Alright, so each rod, they have their let's say we have they said that what is P is P if sigma AB is twice the magnitude of sigma BC. Alright, what is P if sigma AB is equals to 2 BC? So find the sigma AB first. Sigma A is basically force over area. Force over area. Which force? If we cut this A, we cut this one. Okay, we cut this one, it's left with, we cut this one. So this is P. This cut region is also P. Okay, so you have P over area. Area is pi 55. Alright, pi r squared. So remember unit for the stress is force over area. This one is megapascal. This one must be Newton, and this one must be mm squared. Or Pascal is equal to Newton over meter squared. If we use 25 mm, use 25 mm, so you get the sigma is in megapascal, right? So sigma also force over area. If we cut this one, we left you with like this P. Okay. So you have P, have 120, have P. What is P? Say your PBC, right? This one is PBC. Okay. So what is PBC? Okay. So PBC is basically system must be in equilibrium. So PBC plus 120 plus 120 minus P is equals to 0. Alright. So P is equals to PBC is equals to P minus 2440. Alright. P minus 240. Okay. So you can put it in here. So you have P minus 240 over, this is Newton lah, right, over area, right? 75 over 2, 37.5, 37.5 square. Okay, and sigma BC. Alright, so you get this relation, and then you masukkan balik dalam equation ini lah. So you have equals to P minus over 7.5. So you solve this one, you should get the answer. You can try. Okay. You have pi times 25 squared, right? 1 over answer, right? Over 2. Okay. Times shift pi times 7.5 squared. Okay. And then plus 240 integrate. Okay. So you should get your answer around 1. So this is question number 1 lah. Ada soalan tak? Sekejap. Okay, so that's gauge located at C on surface bone AB. The normal stress is 3.8 megapascal, subjected to 0 Newton force. Assuming the cross section of bone is to be annular and knowing that its outer diameter is 25 mm, determine the inner diameter of the bone at cross section at C. Right? So this one is like hollow type, hollow type bone, right? If you have the hollow type bones, okay, we can simply, if we withdraw this, okay, so this one you have for okay, so sigma, so they give you 3, right? So is one uh, area. So area is basically area are square. If I zoom this one into here, my area of this area is R2, right? Okay. So determine the inner diameter. Is given the outer diameter is 25. Outer diameter is 25. So this is 0.5 lah. 12.5. So 5.5 minus R1. You just put here, right? Square minus. Okay. So you should get the answer lah. Much. Then okay. Okay, you can try by yourself. Just given the answer here. D2 is 14.93, 14.73. Normal stress in root AB. If load has mass of 50 kilogram, the diameter of root AB is 8 mm. Okay, this is like your midterm test question. All right, this is just use the rod instead of cable. Right, so you can basically draw the BD. Okay, you can draw the BD. So F and F E and F E. And here right, here is 3, 4, 5. Okay, so you can find FA. You can find the FAB to find the diameter of rod AB lah. Alright. So you do the summation of F is equal to, okay, so you have C over 5 and so we have um, okay. And what is AB? Okay. FAB. So you just put up to you get answer sigma. Okay, I don't show you that. Okay, you can find by yourself. This one is so we have member A connected by a pin and bracket at C. A cable BD was designed to support the 16 kN load P as shown. Knowing the ultimate load for cable AB is 100 kN, determine the factor of safety with respect to the cable failure. Alright. So it's given ultimate load for the cable is 100 kN. Okay, this one for cable is 100 kN. So find the factor of safety. Okay. So remember, or it is always greater than 1. Okay, so sigma ultimate must be higher than sigma allowable. This one should be higher, right? So how to solve this? Basically, we need to find the reaction of BD. Okay, we need to find the reaction of BD. So P is given. Still, P is given still kilonewton. So C is pin. So pin X. Okay, and this is two force member. Only one force. At that location. Zero. Okay. Moment at C is equals to 0. So we have 16. Alright. And then times 1. Alright. 1.2. These two. 1.2. Is the counterclockwise. So it's positive. Alright. Counterclockwise is positive. And then you have the sine 40 times 0.6. Okay. This is 0.6. Okay. Check out the lah dari sini 0.6. And then we have FBD. This one is also counterclockwise is positive, right? And then you have FBD as negative because it's clockwise, all right? This one be here you have B 30. So both are clockwise, so you have F D E. Simple. So you find FBD from this equation. We should, let's see. Okay, you get this answer, and then you put into this equation. The ultimate same. Here as tak bagi okay. Four. Four. Alright. FBD. Factor of safety. It's just reverse. It's given you same is it's given you factor of safety. It's alright. So find the largest force P. Alright. So find the largest force P. Say of this is question number. Yeah. Okay, you put this FBD into this equation, right? Into this, and then find the loop P. Okay, find the P. But now is you know and find value of .73. Question number 6. Same with before. Okay. Force P of rigid arm ABC rotate about pin A at angle 0.02, determine normal strain in wire BD and wire CE. Okay, now it's become like this angle. Okay, so find what's the normal strain for wire BD and wire CE. Okay, for wire CE and wire BD. We can redraw the line. Okay, so this is the and for right, and here and here. Okay, delta L is equal sorry, sini lah. uh, 600 times tan. Okay, so we have the tan times 1200 0.1. Just find the original line of BD, which is excellent. Zero. Oh, question. I will upload the schema at the ULEN later. You can refer. We just show you how it works lah. Alright. Soalan tak?
No.
Ada. Okay. If no question, I think I will end here. Okay. So we continue on the Thursday. Alright. So this Thursday maybe I will give you one quiz so you can answer on the Thursday. So that quiz will have marks lah. Our quiz 3 on chapter 7. Right. I will inform you later regarding the details. Okay. So thank you for your time. So let's meet on Thursday for your quiz 3. Okay. Thank you everyone.